Okay, welcome to the series where we will be discussing previous year questions of AB Physics 1. In this video, we will be discussing question number 4 of year 2025. Okay, so there are two scenarios given. A swimmer holds a block of mass m at rest in a tank of a fresh water with the density ρ1 as shown in figure. The block is released from rest and accelerates upward with an initial acceleration which is given as a1. All friction forces are negligible, so no friction. And in scenario 2, the swimmer holds the same block at rest in a tank of salt water with density ρ2, where ρ2 is greater than ρ1. The swimmer again releases the block from rest and the block accelerates upward with now an initial acceleration of a2. There here it was a1, here it is a2. All friction forces are again negligible. Okay, let's understand the system what we have right now. So in the first scenario, if this is a fresh water case, let's say this is the free body diagram of a mass m. So I can say that the downward force which is pulling it downward is going to be the gravity, that is going to be mg, and the upward force is definitely going to be the buoyant force fb. Let's consider fb, and here this is the case of, let's say, density ρ1. Similar case I can also draw for this one which is the density ρ2. So I'll have same thing, and this is, I can say that buoyant force is going to be ρ1 times the volume times the gravity g. Now this is the density of ρ2, this is where I have the mass mg, and the buoyant force fb is going to be ρ2 times vg. Okay, now what is acceleration? Acceleration is nothing but net force is equals to m net is equals to mass times acceleration. So the more the net force, the more is going to be the acceleration. So net force here I can say it is ρ1 vg minus mg equals to ma, and here I can say that I can write it as a1 and I can write it here as a1, and in this case I will have the buoyant force fb, which is ρ2 vg minus mg is going to be same, m is going to be same, and here I will have is a2. Now given to us there is a condition which is ρ2 is greater than ρ1. This is the condition given. So as ρ2 is, as the value of ρ2 is greater than ρ1, can I say that the buoyant force of ρ2 will also be greater, because vg is constant. If I multiply by a positive value vg, so ρ2 vg is also going to be greater than ρ1 vg. Now if I subtract mg on both the sides, so ρ2 vg minus mg is greater than ρ1 vg minus mg, and this is what we have as ma2 greater than ma1. So I can say that the acceleration 2 is greater than acceleration 1. Okay, so this is what we can understand from these two scenarios. Let's go to the question. What does it say? Indicate whether a1 is greater than, less than, or equal to a2 by writing one of the following. So yeah, definitely a1 is less than a2. Justify your answer in terms of all forces exerted on the block in each scenario. Use qualitative reasoning beyond referencing equations. So I can say that we do not need to reference equation. We can only say that the force, the buoyant force, is directly proportional to the density, and as the downward force which is the gravity force is constant in both the cases, it only depends on the upward force. So more the buoyant force, if the more buoyant force, the acceleration is going to be more. Hence buoyant force is dependent on density. So as ρ2 is greater than ρ1, it simply tells us that the buoyant force of 2 is going to be greater than buoyant force of 1. That tells us that the acceleration of 2 is going to be greater than acceleration of 1. Okay, so this is what we can write over here. Next, consider the general case where a block of mass m and a volume v, so mass is m, volume is v, is completely submerged in a fluid of density ρ. Starting with Newton's second law, derive an expression for the initial upward acceleration a of the block when the block is released from rest. So what we just did, so here I will have the mass mg, and on the top I will have a buoyant force. Here in this case it is ρ vg, the volume is v, the density is rho. Now we know that F net should be equals to mass times acceleration. So F net we have is rho Vg minus mg is downward force is equals to ma. If I divide on both the sides by mass, I will get is rho Vg upon m minus gravity is equals to acceleration a. So this is the expression for initial upward acceleration a. Okay, very good. Now last thing, indicate whether the expression for the acceleration a you derived in part b is or is not consistent with the claim made in part a. So here also I can say that acceleration, the value of g is a constant value, this is a constant value, m is constant, v is constant, g is also constant. So again I can say that acceleration is directly proportional to the density rho. So if the density is more, definitely the acceleration is going to be more. So I can say that the explanation is definitely consistent. Whatever we gave the explanation is part A is already consistent. Now justify your answer by your derivation in part B. So from that derivation I can say that as acceleration is equals to rho Vg upon m minus g, so as acceleration is directly proportional to rho, so if rho 2 is greater than rho 1, hence acceleration 2 should be also greater than acceleration 1. So this should be our final answer. Okay, we have discussed all the questions of free response question of 2025. If you have any doubts, put your doubts in the comment section. I will help you over there. Perfect.